This is AIX, your daily dose of AI news.
Today, we are unpacking the incredible history of artificial intelligence, and it is a story full of these radical shifts in thinking, punctuated by these amazing moments of brilliant insight. It's how we got from simple rules to AI that can actually create. So, how did we get here? To really get a handle on the AI we have today, we've got to go back to the beginning. We're going to trace its journey through 4 pretty distinct eras, and you'll see how each one built on the last, and each had its own big idea about what it even means for a machine to be intelligent.
Okay, so let's jump right in. The first era, this whole period was completely dominated by one really powerful idea, that we could basically capture human intelligence just by giving a machine a set of really strict logical rules to follow. Think of it like trying to write the ultimate instruction manual for thinking itself.
So the thinking back then went like this. Intelligence can be broken down into symbols and logic. In fact, the term artificial intelligence itself, well, it was born at the Dartmouth workshop back in 1955. And just a few years later, you had pioneers like John McCarthy figuring out that, hey, knowledge has to be represented in a clear, explicit way. That really laid the groundwork for this whole first generation of AI. And that whole philosophy led straight to the creation of what they called expert systems. These were really the first big application of AI. The goal was incredibly ambitious. You'd sit down with a human expert, a doctor, a chemist, you name it, and you would try to meticulously codify all of their specialized knowledge into a computer program. Basically bottle their brain.
Now, this quote is a perfect window into that mindset. It's talking about the star player of the time, a system called Dendril, and it shows you exactly how they thought about the problem. It was literally about creating a good list and a bad list, just explicitly telling the machine what to look for and what to avoid, all based on what an expert told you.
So, Dendril's job was to be a super methodical robot chemist. It would take in scientific data, and then, using its built-in rules, it would generate every single possible chemical structure that could explain that data. Then it would just test all those possibilities against another set of expert rules to prune away the bad ones and hopefully find the right answer. And this is what using it actually looked like. I mean, it is nothing like chatting with an AI today, right? This is a structured, logical dialogue. The chemist defines the rules, the constraints, and the machine just logically spits out the answers. It's powerful, for sure, but it's also incredibly rigid. And that rigidity, well, that was the big problem. Trying to handcraft rules for every single situation was brittle, it was time-consuming, it just didn't scale. That, plus some wildly optimistic promises that the computers of the day just couldn't keep, led to this really difficult period known as the AI winter, where all the funding and interest just dried up. But out of that winter, a totally new idea started to take root, a completely different philosophy called connectionism. The question became, what if, instead of programming the rules directly, what if a machine could learn the rules all by itself, just by looking at tons and tons of examples? This was a radical shift. The key that unlocked this whole new approach was an algorithm called backpropagation. Now, the idea had been floating around for a while, but it was its reinvention in the mid-'80s that really changed everything. It was basically the secret sauce, the mathematical recipe for how a neural network could systematically learn from its own mistakes. Probably the easiest way to think about this is like teaching a toddler. You show them a picture of a cat, and they guess dog. You say, nope, that's a cat. The algorithm takes that error, that wrongness, and feeds it backwards through the network, making tiny little adjustments everywhere. Now, you do that a million times, and believe it or not, it actually starts to learn the pattern of cat.
So that brings us to our next chapter. Because see, just having the backpropagation algorithm, well, that was huge, but it wasn't quite the whole story. To spark a full-blown revolution, you needed a few more pieces of the puzzle to fall into place.
And then, in the 2000s and early 2010s, you get this perfect storm. First, the algorithms themselves just got better and better. Second, the internet gave us big data, these enormous labeled data sets perfect for training. And third, and this is the kind of crazy part, researchers realized that GPUs, the graphics cards built for video games, were perfect for doing the math these networks needed.
And we actually got a sneak peek of this way back in 1989. This system, LeanIt, was a huge deal. It used these new techniques to read handwritten numbers on checks, and it worked so well that banks actually used it to process a massive percentage of the checks in the US.
But the real Big Bang moment,
The one that truly changed everything for good happened in 2012.
A model called AlexNet showed up to this big image recognition competition, and it didn't just win, it completely destroyed the competition. The performance wasn't just a little better, it was a revolutionary leap. And from that day forward, everything changed. Deep learning was no longer a side project, it was the only game in town.
So this entire revolution in analyzing and classifying data really just set the stage for the era we find ourselves in right now, which is the era of AI creating data. And things started moving incredibly fast. In 2014, we got GANs, which showed us that AI could generate photorealistic images. Then came the real bombshell in 2017, the transformer architecture. That one paper, Attention is All You Need, is the direct ancestor of the LLOs we all use today. And all of this together is what we now call generative AI. The key thing to understand is that these systems aren't just labeling things anymore, they're creating entirely new things that have never existed before, all based on the patterns they've learned from all that data.
So here's the simplest way to think about the difference. The old way, predictive AI, was all about answering the question, what is this? But generative AI is all about answering the command, create something new for me. The first one can find the cat in the photo, the second one can create a photo of a cat from thin air.
And what's so wild is that this whole story is kind of coming full circle. Right now, researchers are exploring something called neurosymbolic AI, and the whole goal is to merge those classic logic-based, rule-following systems from the early days with the incredible creative power of modern generative models.
I mean, you can really see the progression, right? We went from strict, structured logic to flexible pattern recognition, and now to actual, honest-to-goodness creative potential. It really is a story of constant evolution.
So when you look back at the whole history, you see this constant tug-of-war between two big ideas: logic versus learning, rules versus data. But maybe the future isn't about one finally winning. Maybe it's about finding the best way to bring them back together. And that really is the big question, isn't it? What's the next chapter going to look like?
Thanks for watching.